All right. If we're talking about inverses, we first have to get a couple definitions out of the way. If I want one-to-one, we know if something is a function, then x doesn't repeat. One-to-one means that our y doesn't repeat. So it tells us if we have two different inputs or two different domain values, then they correspond to two different y values. If you put in an x, you get out an answer. If I put in a different x, I have to get a different answer. So if it's a one-to-one function, then our y values don't repeat. So in a function, x doesn't repeat. If it's one-to-one, your y doesn't repeat. So let's start off deciding if some things are one-to-one or not. So if I'm looking at this one, this is a mapping. So I'm giving you essentially a diagram that shows us each piece. So it tells me these are like my x values, these are my y values. Is this one-to-one?
No.
Why?
Two x's equal the same number.
That 38 and the y repeats. Two different x's equal 38. Is B one-to-one? Why?
Because you know that the x is equal to the same one.
Yes. Notation I use for one-to-one a lot is just 1-1. So if you see me write that, that means one-to-one. The y is never repeated here. All right. Let's look at algebraically. So there are different ways to decide if something is one-to-one. If I'm just looking at that, like a list of ordered pairs, it's not so hard. But if I'm looking at the equation itself, I have to have a different option. You're welcome. So what we can do is we're essentially going to prove something. We're going to show that if the y's are equal, then the x's have to be equal. So if f of a equals f of b, then a is equal to b. Here's what that means. One-to-one means y doesn't repeat. So what we're going to do is start out pretending it does. I'm going to say f of a is equal to f of b. So it's saying those y's are equal. Now I'm going to solve that equation. So if I want to get a by itself, what would we have to do? And then what? So we get a equals b. So what we just found is the only way the y's could be equal is if those x's were the same, if a and b were the same number to start with. So when you solve that, if you get a equals b, that means these are one-to-one. It is a one-to-one function, the y can't repeat. If I look at this one, so if I want to decide if y repeats, we're going to start out assuming it does. So let's pretend when I put in a and b, we get the same thing. Then I want to solve for a. So what would we have to do here? Uh-huh. Okay, if I do that, it cancels the radicals. So 49 minus a squared equals 49 minus b squared. If I subtract 49 from each side, negative a squared equals negative b squared. What should I divide by? Okay, then how do I get rid of the square? And anytime you add a square root, what else do you have to put with it? So that means a could be positive or negative b. Okay, what that's saying is I could put in the same thing. For instance, if I put in a 7, I get 0. But I could have put in opposite things. I could have put in a negative 7, and I still get 0. So is this one 1-to-1? No. So if you're using this approach, at the end, if you have a equals b, it's 1-to-1. If you have anything else, it's not. The thing that would make it not 1-to-1 is typically a plus and minus, which happens when you have to add a square root. Right? Any questions there? All right, so we talked about how to decide if something's 1-to-1 if I'm looking at all the points or if I'm looking at the equation. The next option is I might be looking at a graph. If you're looking at a graph, how do you tell if something is a function? Function is vertical line test. So 1-to-1 would be the horizontal line test. So if it's 1-to-1, then your horizontal lines can only touch it in at most one point. So for instance, if I gave you something like this, is that going to pass the horizontal line test? Everywhere I draw a horizontal line, it would only hit once. So that is 1-to-1. If I gave you something like this, no, that one fails the horizontal line test. So that one is not 1-to-1. So just like we did vertical line test to check for functions, we can do horizontal line test to check for 1-to-1. All right. So we are going to check if each of these is 1-to-1. Use what you know about their graphs. Take a second, draw me a quick sketch of the graph and tell me if it's 1-to-1. Squared? No, that's a parabola, so it definitely fails the horizontal line test. Is x cubed? Yes, that's our chair, so it passes the horizontal line test. All right, so are we okay with those? All right. The reason we care about 1-to-1 is if a function is 1-to-1, then we can find the inverse. It has to be 1-to-1 in order to have an inverse. What an inverse does is it reverses the x and the y. They flip roles. So if it wasn't 1-to-1 to start with, when you found the inverse, it wouldn't be a function. So that's why it's important. The symbol for inverse is f to the -1. So that's different than a reciprocal. It's saying the inverse of a function. So if I ask you to find the inverse, if I just give you a set of ordered pairs, the inverse just goes to each ordered pair and flips x and y. So what would my first point be? The next one. Next one. We still have 0, 0, 1, 1, and the last point would be 8, 2. So it doesn't change the values of those numbers, it just reverses them. When we do that, if we look, the domain of my original function, the x's, what did that become in my inverse? The y's. So the domain of the function is the range of the inverse. The range of the original function became the domain, the x's in our inverse. So, since x and y flip roles, the domain of the original is the range of the inverse, and vice versa. All right. So another thing about inverses, they are opposites of one another, so they cancel each other out. What's the opposite of adding 3 to something? Subtracting 3. Okay, so if I said my number is 5, and I want to add 3 and subtract 3, what answer do I get back out? 5. When if I subtract 3 and then add 3, it's still, well, if I'm starting with the number of 5. So if I'm still starting with 5, my overall change, there is no change, it's 0, and so I still get my 5 back. So an inverse cancels out the function, so when you do a composition of two things, if they're inverses, they will cancel each other, and we should just get back the original x. All right, so if I want to use that bit to decide if these things are inverses, we could do the composition. So if they're inverses, when I compose them, I should get x for my answer. If the first one comes out to be x, you do have to check the other one as well. But if one of them is not, you can automatically stop and say they're not inverses. So remember our compositions. You start on the inside. G is 1/2 x plus 3. And what's a composition telling me to do? I plug that into f. So it says you go to function f, and I'm replacing my x with 1/2 x plus 3. All right, we did these compositions earlier in the year. Remember, like your fog and golf. All right, do you guys see what I've done so far? Okay, we started on the inside. G was the 1/2 x plus 3, so I plugged that in. And then I went to function f and I replaced my x with that 1/2 x plus 3. So now we're just going to evaluate this. 2 times 1/2 would just be 1. So those cancel each other. So I get x plus 6. So what does that mean? Are they inverses? No. If they're inverses, what should we get out? If they're inverses, we should just get x. We didn't get x, so they're not inverses. So you can stop right there. But I'm going to go ahead and show the other one just because a few of you were looking at me like I was crazy when I was doing this composition. And I want to make sure you understand. So if one of them doesn't work out, you don't have to finish. You could just stop right there and say they're not inverses. If we did the other direction, that's g of f. F is 2x plus 3. So now you go to function g, and you're replacing your x with the 2x plus 3. So we get 1/2 times 2x plus 6, or x plus 3. So again, we can see they are not inverses there. Any questions right there? Let's try another one. So if I am trying to decide if these things are inverses, we will do the composition. So we're going to do F composed with G. So that means we are going to start with G on the inside. And I'm going to go to function F, and I'm replacing my X with that thing I plugged in. Right, when you do this, now we can start simplifying. Plus 1 and minus 1, what happens? So I have 1 divided by 1 over x. How do you divide fractions? And that just gives me x. Does that guarantee that they are inverses? No, but it says they might be. I haven't proved that they're not. So now we have to check the other composition. So this time I'm starting on the inside. F is now 1 over x minus 1. So I'm going to function G, and I'm replacing my x with 1 over x minus 1. All right, so to divide fractions, so I get x minus 1 plus 1, which is x. So since both of them are x, I can say that these are in fact inverses. Any questions there? Do you guys understand what we're doing with these compositions? Okay, if they're inverses, you have to work both of them, and what should you get for your answer both times? X. If one of them turns out to not be x, what does that mean? Not inverses. Okay, you guys try the next one. All right, so we have to check our compositions. F composed with G means F of G of X. Start on the inside. So, G was this. We have 1/3 times x minus 4. When I say f of that, that means I'm going to function f, but I am replacing the x with the thing I'm plugging in, which was my negative 1/3 x minus 4. Okay, does it matter if you did G composed with F first or F composed with G? No. All right, so now we are just using algebra to simplify this. 3 times negative 1/3 is negative 1. So I get negative x plus 4 plus 4, or negative x plus 8. So are they inverses? No. Now, do you need to check the other way? If one way doesn't work, the other one won't. But I think we're struggling a little bit with these compositions. So let's look at the other way just for practice. G composed with F means G. Guys. So G of F of X. So we start on the inside. F is 3x plus 4. So I'm going to function G, and I am replacing my x with 3x plus 4. All right, so now we simplify. If you have plus 4 and minus 4, what happens? Cancel. So we have negative 1/3 times 3x, which is just negative x. So again, you could see we didn't get x, so they're not inverses. All right, so compositions. We have done them. It's been a while. Remember, we started out practicing like putting in numbers, and then we got to this point. But you are taking one function and plugging it into the other. What questions do you guys have for me? Let's try, or let's talk about one more piece for today. Because an inverse flips x and y, the graph of a function and its inverse are always symmetric over the line y equals x. So if I ask you to graph the inverse of this line, we could start off graphing our line. We should all know how to do that. How do you graph this line? Y-intercept is -2. Slope is 3/1. So from the y-intercept, we go up 3/1. All right, if you think about the points on this graph, we started at 0, -2. What point would be on the inverse? Okay, when I went up 3 and over 1, then my point ended at 1, 1. So what point's on my inverse? Okay, that's enough to draw a line. If you wanted more, I plotted more points on my graph just because I can't draw a straight line. I had the point 2, 4. So what point would that go to? And you could do as many of those as you wanted. And we're getting the inverse. They're symmetric across the line y equals x. That's the line, slope of 0, or sorry, y-intercept is 0, slope of 1. And that goes right through the middle. I think that's the line y equals x that we said it's always symmetric across that line. So I was drawing that in just to show you, if you folded on that orange line, those other two should overlap. I think when you graphed inverses in Mrs. Keller's class, she usually had you plot that or had it already on the graph. So you could kind of do a visual check and see it should be the same on both sides of that graph. All right. Let's do one more slide and then we will probably stop here for today. If I asked you to graph the inverse of this, what would we do? Find the points. Okay, so we just take some points on here. Alright, so this is the point 2, 1. Or sorry, 1, 2. So it will go to
2, 1.
this is 0, 1. So that will become, this is negative 1, 0. Negative 2, negative 2 would stay. Okay, and if you graph the line y equals x, that just goes right through the middle, so we can see it's symmetric on both sides. Okay. I am stopping here for today. There is a Math Excel assignment open. You don't know how to do everything yet. You should be